Alright, let's take a look at one more rational function graph. Alright, for the first step again, let's go ahead and factor these polynomials. So in the numerator we have a quadratic. Alright, I'm going to go ahead and factor that down to its two linear binomial factors. We need a 2x and an x up front for the 2x squared term. Alright, we know with our constant term being 2, right, our factor combination is 1 and 2. And yes, we can use those to work together to make the middle term coefficient of -3. So to do that, we're going to need a 2 here on the outside and a 1 on the inside. And that would need to be a minus and a plus here. So the outer product would be -4x, inner product would be 1x, and they add up -3x. 1 times -2 is -2. So there's the two linear factors. Numerator. And denominator, we've got x minus 2. Well, already in simplest form, nothing to factor. Now you see it does reduce. We have that common factor of x minus 2, so we are going to have a hole in this graph. Now notice what it reduces to, a linear, right, polynomial. So a line, a linear function, slope-intercept form. Now, talking about a linear polynomial, horizontal asymptote, we're not going to have a horizontal asymptote. There is none. Right, and the reason for that is, again, if you want to go back to degrees too, you can compare at the beginning. Degree of numerator was 2. Degree of denominator was 1. N is 2, numerator degree. Denominator was 1. N is greater than m, right, in this example. Only time we have a horizontal asymptote, with n is less than or equal to m. So again, with n greater than m, no horizontal asymptote. It has to be less than. If it is less than m, it'd be y equals 0. If n equal m, it'd be the ratio of leading coefficients. So with that said, no horizontal asymptote, which, yeah, when we graph this linear here in a minute, we're not going to see it flatten out anywhere horizontally. It's got a slope of 2. It'll be increasing. With that said, we mentioned our common factor of, what? X minus 2. So with our holes, so remember, where is the hole located? 0 of the common factor. Right, be the location of the hole. So yeah, x minus 2, the common factor, equals 0, and x equals 2. So we're going to have a hole at 2 on the x-axis. Now what does y equal? So let's go ahead and evaluate. What is f of 2? So that'll be 2 times 2 plus 1, which is 4 plus 1, or 5. So y is equal to 5 when x is 2. So we're going to have a hole at the ordered pair of 2, 5. So 2, 5, and we're going to plot that, right? 2, up 5. 1, 2, 3, 4. Right here. We're going to have a hole in our graph at that point. So again, I'm going to label that. So our line, again, we're going to graph a little bit because it's a linear polynomial left. It's going to have a break there, a point of discontinuity. Now, domain, we can go ahead and write it in domain. Domain is going to be what? All the numbers except the holes, or any vertical asymptotes. Now, we should talk about vertical asymptotes next. What are the vertical asymptotes? The zeros of your remaining denominator factors. So there is no denominator remaining. There is no vertical asymptotes on this one, right? No factor, right, remaining in the denominator. If we had a factor left over after reducing it, we would have the 0 from that being the vertical. So yeah, the domain will be all real numbers except location of that hole. So x less than 2. So we'll see our graph take place from the left of 2 on the x-axis, or to the right of 2 as a break at 2. There's our domain. Alright, let's go ahead and find the x-intercept. So the x-intercept, what do we do to find x-intercepts? We're going to let our function equal 0, right, and solve for x. So what do we get? 2x plus 1 equals 0 when x equal what? -1/2? So at -1/2, we're going to have a x-intercept. So at -1/2, 0. We can go ahead and plot that point right here. -1/2, 0 is the x-intercept point. Now, what's the y-intercept? Y-intercept is going to be what? 1. Right, it's the constant term. Of course, you can show our algebra. We let x equal 0. Right, let's go ahead and show our work. We can plug it in. What's f of 0? 2 times 0 plus 1, which is 1. So yeah, y-intercept is at 0, 1. The constant term, the location of the y-intercept, right here at 0, 1. Plot that point. So we got enough information to graph it, and you want to get more detailed, you could. We know, again, with the slope being 2, up 2, right 1, it's going to pass through the point 1, 3 also. But again, I'm going to go ahead and graph it in. So I'm looking at the graph of this line here. All right, we can go ahead and sketch that in. So we're looking at our graph here. All right, we got a hole there. And there's a sketch of this graph. And we've got a couple points that we've labeled, right? Give us some characteristics. So with that said, you can see our sketch of this graph. Again, more points you want to plot, you could be more detailed. All right, but again, that's a rational function graph, but notice simplifying it. What did it do when we simplified? We ended up reducing down to a linear polynomial. So we graphed in that linear polynomial, this line of 2x plus 1, but had a point of discontinuity at 2, being that's where that common factor was, had a hole in it. So again, I hope this example helps you.